Okay, pre-calc. Hope you guys had a good weekend. So we're moving on to our next lesson. We got a little bit shorter of a week here, and then we got a week off for spring break. So what we've done up till today with our trig identities is evaluate functions and also simplified trigonometric expressions using our identities, which, remember, that's that big old sheet that you hopefully had printed out here that has all these different identities. Today we're going to do what we call verifying identities. And all this is we're going to take two things that are equal to each other and we're going to prove that they're equal. And so the way we're going to do it is we're going to rewrite one side of our equation until it looks exactly like the other side of our equation. So to rewrite, we're going to use all our identities. What I like to do is I actually like to list out which identities I'm using just to keep track of everything. So we're going to go ahead and do that as well. And the biggest hint here to use is written right on the left. Work with the side that looks more complicated. It's actually easy to get from more complicated to less complicated than the other way around using our identities. So for number one, it looks like we're trying to get from cosecant times cosine squared plus sine equals cosecant. So we're trying to prove that this is equal to that. So we have to rewrite this a bunch to prove that it's going to be the same exact thing as cosecant, right? So the first thing I'm going to do is I'm going to use my reciprocal identity, which means I can rewrite cosecant as 1 over sine, right? Okay, so right there, now I have sines and cosines. That's nice. I'm also going to go ahead and write this in a single fraction. So it's just going to be cosine squared over sine plus sine. Right? And what you'll notice is we have two expressions here separated by addition, but we want to get to just a single expression, just cosecant. So what I'm going to do is I'm going to somehow get these guys so I can write them as a single term. The way I'm going to do that is I'm going to actually have to get a common denominator. So the denominator here is sine. To get the denominator over on this side to be sine, right now it's just 1, right? I'm going to have to multiply by sine over sine, right? So at this point, I'm going to have cosine squared plus, on this right side, our new numerator is going to be sine squared. And now the whole reason I did it is so I could have a common denominator. Okay. And then after that, now that I have a single function, let's see if we can simplify it down. Cosine squared plus sine squared, using my Pythagorean identity, I can say that cosine squared plus sine squared is actually equal to 1, right? And then finally, using my reciprocal identity, I can go ahead and say that 1 over sine is equal to cosecant. Okay, so just a rehash of what we did. We started off with reciprocal, okay, and then we combined these guys into a single fraction, and we noticed, hey, we want to get a single term here, so we got to get a common denominator. So I multiplied the right fraction by sine over sine. And when I combined them, I noticed that I had the Pythagorean identity opportunity here. Cosine squared plus sine squared is equal to 1. And then I used the reciprocal identity to prove that it is equal to cosecant. And so that's all we're doing when we're trying to go ahead and solve these guys out. Okay? So another thing to keep into account is you know what you're trying to get to. So keep that in mind when you're deciding how to change things. For example, if you take a look at number 2, we have sine squared over cosine equals secant minus cosine. So these guys are almost like equally complicated. So I'm just going to start with this left side right here. Okay? And it looks like I have sine squared over cosine equals secant minus cosine. So I've noticed that both my terms on the right side that I'm trying to get to both involve cosine, right? Secant is 1 over cosine and cosine is just cosine. So I'm going to think of ways that I can rewrite sine squared as something with cosine. And if you take a look at our Pythagorean identity, which, remember, is this guy right here, if I rearrange this guy a little bit, I can say that sine squared is going to actually be equal to 1 minus cosine squared, right? So I'm going to replace that guy with 1 minus cosine squared. Right, so that was my first move I used. That was my Pythagorean identity. Right, and then what I can do is I can actually break this guy up a little bit. Right, I can rewrite it as 1 over cosine minus cosine squared over cosine. And the reason I did that is because I know my answer that I'm trying to prove that this guy is equal to actually is separated by subtraction. And I think this is pretty much it here, right? We use our reciprocal identity right here, and that's equal to secant, right? And then cosine squared over cosine is equal to cosine. And we got to what we were trying to get to. Okay, so let's have you go ahead and try out number 3 on your own. So pause the video and give it a go. I would suggest starting with the right side, which looks a lot more complicated. All right. So once you unpause, let's run through it. So I'm trying to get from sine squared times cosine squared minus sine squared to just cosine squared. Okay, so the first thing I'm going to do is I'm going to go ahead and I'm going to rewrite this cosecant squared as 1 over sine squared. Okay, so I use my reciprocal identity to start off. And what you'll notice is these guys are just going to cancel. I have sine squared over sine squared, and I'm just going to have 1 minus sine squared. And we want to get from 1 minus sine squared to cosine squared. That's definitely our Pythagorean identity. If we take a look at that guy, which remember is cosine squared plus sine squared equals 1, and we rearrange it a little bit by subtracting sine squared, we can actually say that this guy is equal to cosine squared, which is what we were trying to get to. So that was just 2 steps there. Right, so let's go ahead and check out number 4 here. This one definitely, starting with that side, looks a lot more complicated, right? We have tangent of x of secant of x over tangent x minus tangent of x secant of x equals cosine. So a ton going on. Okay, the first thing I want to do is I want to go ahead and I want to make this a lot simpler. Okay? So first off, I got to get it into a single fraction. That means getting a common denominator, right? So I'm going to multiply this fraction by secant of x over secant of x, this guy by tangent over tangent, and then I'll be able to combine them into a single fraction here. Okay, so all I did to get from here to here is I multiplied this fraction by secant over secant. It gave me secant squared up top and gave me that denominator of this. But on this side, I multiplied by tangent over tangent, okay, and then I was able to combine them into a single fraction. And then what you'll notice is secant squared minus tangent squared. Using our Pythagorean identity, you should know that that guy, okay, if we rearrange this right here and just subtract tangent squared, okay, we end up getting 1 equals secant squared minus tangent squared, which is exactly what we have here. So that's actually just equivalent to 1. The other thing you'll notice now that we've simplified down this much is that we have tangent over tangent, right? So those tangents cancel, and we have 1 over secant. And using our reciprocal identity, 1 over secant is equal to cosine of x. All right, so let's look at 2 more. It looks like number 6, we're going to have a little bit of the even-odd identities. So we're going to have to keep an eye out on those. Make sure you have that front page there waiting for you. All right. So for number 5, we're definitely going to start off on this right-hand side, which looks a little bit more complicated, right? And we're trying to get from cosecant squared minus cosecant squared times sine squared to cotangent. Okay, so cotangent, I know, involves some sine and cosine action. So at some point, I'm going to try and get sine and cosine involved. We already have a sine there, so let's see what we can do. First, I'm going to go ahead And looks like we have a GCF. So I'm going to pull that out. Right. So I got cosecant squared, and I'm left with 1 minus sine squared. Using our Pythagorean identity, we know that 1 minus sine squared is actually going to be cosine squared. Right. We just rearrange our Pythagorean identity. And remember, cotangent squared, which is what we're trying to get to, is cosine squared over sine squared. And if we rethink cosecant squared using the reciprocal identity, we can actually think of it as 1 over sine squared. And if we just put these guys together and use our quotient identity, we are equal to cotangent squared. Yep. And then we got this last one that we're going to do for today is number 6. We have tangent of negative u times sine of negative u plus cosine of negative u equals secant of u. Okay, so we're going to try and use our even-odd identities to start off whenever you see there's negatives. So the first one, remember, go back to your trigonometric identities page, and the even-odd guys are these guys right here. Okay, so if you're taking a look at those, you'll know that we can actually rewrite tangent of negative u as negative tangent of u. Yep. And then you'll also notice that we can rewrite sine of negative u as negative sine of u. We can just pull that negative out in front. And you'll also notice that cosine of negative u is actually just the same thing as cosine of u. Okay. And then a few things are going down here. Okay. So first off, we have this negative tangent of u and negative sine of u being multiplied, so they're just going to end up being positive, right? So we get something like that. And then we can go ahead and we can combine these guys a little bit. I'm going to rewrite tangent using my quotient identity as sine over cosine. And then if I multiply these guys, am I going to actually get sine squared of u cosine of u plus cosine of u. And then to get a common denominator, so these guys can actually combine into a single guy, because remember our goal is to just get secant. We want a single expression here. I'm going to multiply this side by cosine over cosine, and it's going to give me cosine squared over cosine. And then you'll notice once we combine, we have a Pythagorean identity situation. Sine squared plus cosine squared is equal to 1. And then finish off, 1 over cosine is secant. Okay, so just like when we were simplifying trig expressions, sometimes you got to do a little trial and error. So you got to try a few things out, see if it's leading in the right direction. Okay, so don't be frustrated if you have to try a few times. That's pretty common. Okay, so what I want you guys to do to practice is go to